Alright, so good morning, good afternoon, good evening, whenever time you're watching this. Okay, so set theory, right? Now, a lot of people are having difficulty with this subject. Not subject, well, this part of the subject, Maths 130, which is set theory. Now, I'm going to explain to you a very simplified way of learning set theory, especially the bases, because once your bases are alright, you can obviously apply the question very, very easily. Now, one thing about maths you have to understand is that you have to create a picture in your head. Okay, if they say what's A union B, don't expect yourself to just know what A union B is. You need to say, okay, you know what is A, what is union, what is B, create that picture in the background, and then you'll know what it is. And I'm telling you, if you create that picture, no matter what question it is, you don't need to memorize what the question means. You just need to go by part, which I'm going to teach you the techniques now. So firstly, what is set theory? Now, it deals with sets, okay, sets of different things, okay. Now, to call a set in maths, we say, let's say we call the set A, alright, set A. And in that set A, it has, let's say, 1 and 3. So we'll say A is equals to curly brackets. Remember, curly brackets. Do not do the square bracket because that's wrong. 1 and 3. And let's maybe put 5 up here. Alright. So in this set A, there's 1, 3, and 5. Okay, now let's do another one, right? Let's say this is set B. Now it can be any letters, but I'm just going to use this B. Now let's say B is 1, then let's say 8, and let's say 9. Now as soon as you see this, right, you basically are okay, these are the sets. But this is what I'm teaching you, is to do a technique and draw it, okay? So I want you to picture two boxes, right? So let's do it. This box over here is A. Okay, I know why that thing disappeared. 1 second. Alright, so as you can see, there's two boxes. And it doesn't matter what size the box is. Because if you get two boxes that are different sizes, but put like two objects in either one of them, it's the same thing, right? So in A, we got 1, 3, and 5, right? So 1, 3, and 5. Okay? And then in B, we got 1, 8, and 9. Alright, 1, 8, 9. So these are two boxes. And I want you to picture this in real life. You got two boxes and you put these two. Now, let's start with the basics questions that they'll ask you, right? So one of the basic questions they'll ask you is this. What is A, let's see, then maybe ask what is A or B, right? Which is also known as A union B, okay? A union B. So you'll get something like this, A union B. Now, as soon as you say A union B, I want you to emphasize the fact of a union. Now, what does union mean? It means all together, okay? Union all together. So basically what it's saying, just put these all together. Put all the elements all together. Okay, so I forgot to say these are elements. So 1, 3, 5 is element, 1, 8, 9 is an element. Alright, so A union B. Put all the elements together. So it'll be 1, it'll be 3, it'll be 5, it'll be, now this is repeated 1, but we already repeated, so it's fine. So it's 8, 9. So obviously you have to put the curly brackets. That's 1, 3, 1, 3, 5, 8, 9, okay? 8, 9. So this is the answer for O, okay, for union. Union is also O, it can be all together, so 1, 3, 4. Now you don't repeat that 1. So this is the answer for A union B, which will get very, very common. Now if they ask you what is A and B, which is also known as the intersection, so A intersection B. Now A intersection B, now what is this? Basically saying, okay, you got the two boxes now. Tell me something, which elements are in both boxes? So in A, I mean, we can clearly see there's a 1 here, and in B, there's a 1. So that's it. In two boxes, there are two of the same elements. So just put 1. We don't have to put the other one because it's repeating. We don't care about repeating. We just want one element. So there we go. A and B is 1. Let's say if we had 3 enough for argument's sake, then obviously it'll be 3, 3. So it'll be 1 and 3. 1 and 3. So it'll be 1 and 3. So that's basically A and B. Now this is the basic. Obviously now we'll go more further into detail. Okay, so this is another example. Now, you don't have to draw boxes for everyone, but in the exam or when you're doing it, it's good to draw boxes. And you don't have to draw boxes, you just imagine it, right? So this is like one box which is A, this is one box which is B. Now, if I say now A union B, A or B, like we did on the previous example, obviously it's going to be 2, 4, 6. So A union B is equals to open curly brackets, 2, 4, 6, 3, 5. Close brackets, curly brackets. So that would be the answer over there, right? Just putting all these together. Now, if they say this, right, what is A intersection B, or also A and B, where they got like A and B, like that sign, A and B is there. Now, when you look over here, right, what they mean is, okay, there's two boxes. Which one, or many, or how many got like both the same items in those two boxes? They got 2 over here, there's no 2 there. 4, there's no 4. 6, there's no 6. 5, there's no 5. 3, there's no 5. So there's nothing right. Now when you come to this scenario, we call something an empty set, right? So it's like a circle with a tick mark like that, but it's not like a tick like that, but like the line, like tick line. So this is called an empty set. So the answer, if it'll be A intersection B, alright, also known as A and B, same thing. A and B will be and the empty set, right? So basically what it means, there's nothing in the set. This set right here, it's empty. There's nothing here, which makes sense, right? There's no numbers you can put in here. So therefore this becomes the empty set. Now, okay, perfect. So we got A union B, A intersection B, we got the empty set. Now what is this? It's basically like a 3, but like a messed up version of 3, like it just went to reflect like a mirror 3. When you see a mirror 3, it basically says it's the universal set, okay? It's called the universal set. Now what does universal set means? Now if you picture like a Venn diagram, okay? Let's say we put A over there, A, and then we put B. Now obviously there's no intersection because there's no A and B, which we proved before. So the A, B, and obviously all the numbers will be 2, 4, alright, 6, and B will be 3, 5, 3, 5. Now, what is this universal set? It basically means everything in this whole rectangle, everything. So in this case, the universal set will be 2, 4, 6, 3, 5. So it'll be there. But sometimes you'll have like a number over here, right? So now it'll be 2, 4, 6, 3, 5, and it'll be 2. Okay. Also, I forgot to add is this. When we say 2 is an element. Now, element is like this. Element of A. Is this true? Yeah, it's true. 2 is the element of A. Because this is A and these are all the elements of A. Now 2 is an element of A, that's true. 2 is over here, so 2 is an element of A. If I say is 8 an element of A. Now, okay, element of A, is the 8 in the elements? No. So now obviously if that is untrue, just put like that. So it's basically like a sign like that. Okay, so that means it's not an element. So yeah, that's one of the things you need to know also. Okay, so now this is when it gets tricky and most people, mess up from here. Is when you get 3 elements. Now, most likely you are going to get 3 elements, but it's fine. Just imagine 3 boxes. That's all. You got 3 boxes in front of you. All these are in box 1, box 2, box 3. If I say what's A union B, obviously it's going to be 2, 4, 6, 3, 5. But now, how do I say A union B union C? How do I put everything together, right? Now you maybe came across this and got really confused because it's something which you never ever seen in your whole entire life before. It's this. This is A union, open brackets, B union C, and you would have found this in your tutorial questions. So this is easy, right? It's basically saying, first of all, anytime when you come to this, something that is like this complicated, work it out in steps. So the first step is I'm going to put A, alright? And I'm going to see, okay, what I got in A? I got 2, 4, 6. So A is over here, alright? Now, I can rewrite it down, but I'm just putting it for argument's sake. And then work out what's B union C. B union C is obviously going to be this, alright, and it's going to be this. So basically it's going to be 3 5 2 5 1 3, and then A is going to be 2 4 6 3. But now the third step is to be like, okay, you know what, what's this? Or. So basically it's saying whatever you got for these numbers, whatever you got these numbers, just add them together, put them together, unite them together. So the answer to this will just be it'll be 2 4 6 3 5, and obviously you got 2 repeats, don't have to say that. 5 got repeated, okay, 1, and yeah, you got that's the answer. So basically it's another way of saying put everything together. A union A or B union C, put everything together. In fact, these brackets don't even like need to, but they just confuse you. But that's what it's saying. Now we look at the opposite, A and intersection. Alright, so as soon as you see this, you're like, oh no, wait, what's happening here? You got A union, open brackets, A intersection C. So you got intersection, union. How are you going to do it? I mean, you got 3 elements. Chill, calm down. Step 1, what's A? A is 2 4 6, right? Step 2, what's over here? It means A and C. So basically saying what's common between A and C. In those 2 boxes, what elements are the same? So if you look at A and we look at C, we got 2, so that's perfect. That's nothing. So the only thing is 2. So you can, I mean, put 2 over here. And then A, obviously, you put all the numbers over here. And then now it's saying A or. So it's basically saying add this to that. Okay, A or, unite them together. So 2, 2, now obviously you don't have to put 2, 2. You can just put 2, 4, 6. That's the answer. Now, sometimes they'll give you this and say simplify fully. So you can just write this is equals to A. You know, I think you saw this in the tutorial where they say simplify. It equals to A. Because check, we got 2, 4, 6, which is A. So indirectly, you see how it links. That's what I'm saying, draw. If they just tell you this and say simplify for like a symbol or something, then you can work this whole thing out like what we did over here, and you can prove that that's equal to A. Now remember, in the exam, you're going to get like 4 marks for this, right? Obviously, when you work, you'll only get this question here. Then the second line, put A is equals to whatever set, basically this. So your step 1 will be that. Step 2 will be A and C. Or you can put like this, B and C. And then next step you can say A and C. And then add this and A and C together to show like how you did it. But as long as you show this A, B and C and you got the answer is correct, because the only way for you to get the answer is this. So this is like the complex, but it's so simple because I showed you how to imagine a picture. You got boxes. So this is the simplest part of it. Another thing which they can ask is what is not A? So it'll be like a A with a sign over here. So not A will be the set. Now as soon as you see not A, right, whatever elements are in A, you ignore in the whole set, right? The whole set, you just ignore it. So 2, 4, 6, wherever you see 2, 4, 6, just ignore. I put everything, right? So 3, 5, we put that 3, 5, 2, oh no, we can't put 2 because it's not in A. 5, we can put 5, and then we can put 1. So that's the answer. So when saying not A, you look at everything besides A. Even if A elements repeat over here, you ignore them too, because this somehow mixes with A, okay, they're intersecting. So yeah, that's not A. If I say, what is not A and B? So it looks something like this, right? Not A and B. So it's not the A and B. So what is A and B? A and B, okay, in this case there is no A and B, it's an empty set, but let's say you got your 2. Now obviously 2 and 2, so A and B will be 2, 2. So A and B will be 2. So not 2. So just do not put 2 in your answer. It will be 4, 6, 3, 5, 5, 1. So that's the answer, okay? You just ignore that. Not that, you just ignore. So not A and B can also be written as, so just ignore this, right? Just ignore this. It can be written as not A and not B. Exact same thing. We'll know how to prove this later, but exact same thing. So yes, so this is part 1. This is the easy stuff, and it's complex, but you know what to do.